Hi, welcome to Stair Tailored. This is Jessica Mao, and I'm with the University of Texas at Austin. This is the last video of a 4-part series on multiplying linear expressions. In this video, we're going to look at how to use graphic organizers and how to support students in solving linear expressions in contextualized word problems. Now, before we continue, let's briefly review the CRAI model, which is presented in Strickland's 2017 article. So CRAI, which stands for Concrete Representational Abstract Integrated, which is the same thing as Concrete Pictorial Abstract, essentially means that there's no particular order, sequence, or hierarchy in which we have to present the representation. As for students with mathematics difficulties or disabilities, the more tools such as manipulatives or visual representation that they can access, the easier it is for them to really relate them to the abstract form of mathematics concepts. So we want to make sure that students are able to get a chance to explore manipulatives and pictorial representations, which I'll talk about in a minute, to be able to access the different strategies and approach solving problems like linear expressions. On the way from pictorial representations to abstract representations, it is helpful to introduce students to a graphic organizer. And this is where the box method comes in. So we can use this graphic organizer to solve or multiply a linear expression. And let me show you. So our example is x plus 5 times 3x minus 4. We have two factors, x plus 5 and 3x minus 4, and each factor has two terms. So in this graphic organizer, we're going to identify each term and then multiply them and to find our final product. So here on this side, I'm going to take the first factor, which I'm going to write x and 5. And note that this 5 is a positive 5. So throughout, while you're modeling this graphic organizer with your students, we can use think out loud to process each of the step and why. And here, I'm going to identify the second factor with 3x and negative 4, right here. And now, in this box, I'm going, with each square or each box here, I'm going to multiply the terms that are aligned in the rows and columns, okay? So in this box, I'm going to multiply x with 3x, which I will get 3x squared. And here we have 3x times 5, positive 5, then 3 times 5 is 15, and then multiplied by x is 15x. Now here we have negative 4 times x, or x times negative 4, which gives me negative 4x. And finally, we have positive 5 times negative 4. So we have positive and negative, and we have multiplied those together, we have one negative value, which is negative 20. So now that I have these four terms, I'm going to combine all of the terms into one single line. So I'm going to write them down here. So I start with 3x squared from this box, and I'm going to write down this box, which is positive 15 or plus 15x. Take this box, negative 4x or minus 4x, and then finally minus 20 or negative 20. And we combine, we're looking for like terms, right, to simplify this expression. We have these two like terms in which we have positive 15x minus 4x, which will give me 11x. So I'm going to rewrite this answer to 3x squared plus 11x minus 20. And that will be my final answer. So here we can use the graphic organizer to show students how to use this as a pictorial abstract to help students organize their understanding of each term or each factor, and then multiply them, and then find the final result. So make sure to give your students a lot of opportunities to use a graphic organizer to multiply linear expressions. And once they're comfortable using that graphic organizer, then we can transition them to solving contextualized problems. So here we have an example of a contextualized problem partnered with a table or a graphic organizer. And when we solve these, I like to use what's called an attack strategy to help me. So an attack strategy, one of my favorites, it's UPS check. Each of these letters in the check tells me what to do when I solve contextualized problems. So the first letter U stands for understand by reading. And in this case, I'm not only just reading the problem, I'm really trying to understand the problem by either highlighting or underlining important words that tells me what the problem is about. So let's read it. It says, Liz, Joe, and John want to expand their gardens. The length can be increased by 3 feet, and the width can be increased by 2 feet. So here we have a table of each of these 3 people, and as well as an X stands for any garden, and it looks like we're going to expand every single garden here. So I think I understand the problem, but I'm actually going to underline the word length here because it seems important, as well as width. And they're here in the table, length, width, and here's another column called new area. So I'm going to underline this because it seems important where I'm going to solve for that. So I'm underlining what I think is important and what I think the problem is about. So I understand it and I read it, so I'm going to check off U. Now the next part is P, which stands for plan. And in planning, it seems like there's going to be multiple steps. So I'm going to take my time to figure out what I'm going to do with each step. So the first step here looks like we're going to fill out the table by figuring out the length, the new length in feet, and then the new width in feet, as well as the new area in feet. Let's do that. So here we have Liz. She started with the 4 feet of each side, 4 feet of each side, and the length, when we have increased it by 3 feet, actually I'm going to take some notes here. Put some little note to show that this column is going to plus 3, and then the width is going to plus or add to 2. And then now in area, might be where you can have a discussion with your students about the meaning of area, which is we know the formula of length times width. So hopefully it'll be a refresher for your students on in this topic. Now we have Liz, who started with 4 feet of a side, and the new length when we add 3 will give me 7. And then the new width when we add to 2 will give me 6. The new area in which we have length times width, 7 times 2, it gives me 42. So we're done with Liz. Let's take a look at Joe. Joe, we have 5 plus 3 is 8. And then 5 plus 2, 7. And finally, when we multiply length times width to find the area, we have 56. And the last person, John, we start with 7 feet, and when we add the length, we have 10 feet. And we add the new width, we have 9 feet of width. And then finally, the length times height times 10 times 9 gives me 90. All right, so we have figured out all of the new area of the gardens of each person. And now we have an X, an unknown. So I think here's where the second part comes in. We're trying to figure out what is that new width, new length, new width, and then the new area. This part is easy because any length adding 3 is that length, so we can represent that as x plus 3, and then any length times plus 2 is x plus 2, width plus 2, and here is the last part. And this is where I might utilize the graphic organizer we used previously in this video to multiply these 2 factors. All right, so now we're going to use a graphic organizer that we used previously in this video to solve the product of these 2 factors. I'm going to draw the box right here. So here I'm going to write down the terms for this factor, which is x plus 3, and then the terms for this factor, x plus 2. I'm going to multiply each one to find the product of each. So it's x squared, 3x 2x, and 6. And now I'm going to combine all of these products into my final answer, which is the area, and I think this solve finishes my part 2. So I'm going to write x squared plus 2x combined with 3x gives me 5x, and I'm going to write down the last term, which is 6. So here's my answer for finding a new area of any garden, unknown garden. So I've actually done the planning as well as solving, which is what S stands for. And now let's quickly check our answer. So here we see 7 times 6 equals 42, 8 times 7 is 56, 10 times 9 is 90, and then x times x plus 3 times x plus 2 gives me x squared plus 5x plus 6. And this makes sense, especially when I checked over my matrix again. Thank you for watching this Dear Tailored, in which we talk about multiplying linear expressions. Make sure to check out our other videos on factoring linear expressions and other series.